And I should probably do, I don't see where that is anymore. They used to have the live transcription, but all right, let's go ahead and start the webinar up. And
for me, it still says you were in a practice session, but I see participants coming in.
there we go.
Now it's live. Great.
Greetings. And make sure we are recording. We are recording. Fantastic. And greetings, everyone. Thank you so much for joining us on this actually beautiful afternoon here in Austin, Texas. So today we have our first webinar series of 2022, and thank you very much for joining us. If you have a chance to check out the Designsafe website, please go there. There's some really cool stories coming up right now. One of them is the SHEAR has started collecting some perishable data from the post-tornadoes that came across earlier at the end of last year. And of course, just a quick reminder that we are still accepting dataset award nominees for the 2022 dataset awards. Just the nominations are open through the end of this week, so feel free to please get those in. Also, I want to give a heads up that we really appreciate your all's feedback that we've gotten over the past few webinars. There is a QR code. Feel free to scan that with your phone and fill out a quick survey that allows us to basically bring you webinars like these that are interest of yours. Also, if you have any interesting data sets or interesting technologies that you've used or applied Designsafe to, feel free to share those thoughts with us as well, and we might put you on, the spot and have you present a webinar for us as well. So yeah, feel free to please give us your feedback. We really appreciate it, and it helps us move forward with our webinars as what we have planned for the rest of the semester. So today we're bringing you a Jupyter Tapas workflow for running ensemble simulations using ADCIRC. I'm pretty sure you all are familiar with the ADCIRC app. That is actually one of the apps hosted here on Designsafe, but it's a high performance cross-platform numerical ocean circulation model, and it's used to simulate storm surge, tides, and coastal circulation problems. Using ADCIRC to do kind of a one-off simulation is pretty simple. A lot of you do that. When it comes to expanding on ADCIRC to do multiple coordinations of large batches, it gets a little challenging. And Clint Dawson, Benjamin Panchev, Pachev, and Carlos del Castillo Negrete are here with us today to discuss their novel approach to this. So if Clint Dawson, of course, is a familiar name in the Designsafe community, as he is one of our PIs, and Benjamin Pachev and Carlos del Castillo Negrete are PhD students in the computational hydraulics group at the Odin Institute here in UT, and very much looking forward to their presentation today. So with that, I'm going to hand this off to Benjamin. Thank you very much. Or I guess I'm handing off to Clint.
Let me just say a word.
Please.
First of all, we just appreciate everybody for joining us on such short notice. I want to say a little bit about the motivation for this project. So why are we interested in running ensemble simulations using ADCIRC? Well, there's a number of applications where you might want to run ensembles. For example, if you're doing inverse modeling, if you're doing uncertainty quantification, any type of statistical simulation where you want to understand like the impact of say a storm that is running on different tracks or has different parametric fields associated with it, then you need to be able to sample, and to do that you have to run forward simulations. And so that's one of the motivations for being able to run ensemble calculations. So with that, I'm going to hand it over, I think, to Benjamin first, and then Carlos will go.
All right. Well, thank you, everyone. Can you all hear me?
Yeah, we can hear you.
Good, slides are working. So a little bit about our group, the computational hydraulics group. We are part of the Odin Institute here at UT Austin for Computational Engineering and Sciences. And we, as the name suggests, do anything with water. Storm surge is very big. The ADCIRC model was in part developed by our group a ways back, and we also, in recent years, have been using Designsafe a lot to share data and to collaborate. So all of you are probably familiar with ADCIRC. It's a finite element code, solves the shallow water equations, and we used a lot for storm surge. Designsafe does have a couple different flavors of ADCIRC that you can run as an app, but currently does not have a way to run ensemble simulations. And that is what we'll be talking about today. So Clint touched on this a little bit, but there's a number of reasons why we would want to run ensemble simulations. Any kind of MCMC method or inversion problem will require a lot of forward simulations. Another application for these ensemble simulations is in developing reduced order models. You need a lot of data in order to do that. Or for different machine learning tasks, it can be helpful to have a lot of data. Now, there are a number of problems that arise when you try to run an ensemble simulation. One of the problems is that you need lots of resources. And so you want to use those resources efficiently. You don't want to get halfway through your ensemble simulation and find that you've been doing things wrong, or have your job wait for a week in the queue only to fail. So you want to have some good software engineering around this. These ensemble simulations are also very painful to set up, and that makes them painful to share. And so our goal has been to develop frameworks and codes that allow us to set these things up very easily for a variety of problems. And we would also like that to be easy to share with other people. So there are two main components that we have been using to develop these ensemble ADCIRC applications. The first is called pylauncher. This is an application that was developed by TACC that is just a framework for running any kind of ensemble simulation. So not necessarily ADCIRC, anything where you have a lot of the same executable running in parallel. This allows us to submit an entire batch of simulations as a single job. Whereas the more manual approach would be to just submit your simulations one at a time. Maybe you have a little script that goes and submits 20 jobs. That ends up being a lot less efficient because each one of those has to wait in the queue, and you always have to pad your jobs. So you end up wasting time. And so using pylauncher is one big thing that has allowed us to use HPC resources a lot more efficiently. The other benefit of pylauncher is that you get this abstract representation for ensemble simulations. You can just specify it via config file. And so you only have to solve the problem of splitting up your ensemble simulations across different nodes once, and then you just change your config file, and you can do another problem. The other nice thing about pylauncher is maybe, let's say you have a very complicated workflow. Maybe you want to run a batch, and then depending on the results of the batch, you kick off another simulation, but you like to do that within one job. Using pylauncher, it's possible to develop these kinds of applications with a little bit of work. So the other main component to these ensemble simulations is another tool that has been developed by TACC called TAPIS. And what TAPIS is essentially an API for HPC. So this allows workflows, job submission, job monitoring to be automated and to be run by people who don't have a TACC account. Whenever you go into Designsafe and you run an ADCIRC app or another app, a lot of the time that involves TAPIS under the hood. TAPIS has the capability to let you develop an application and then share it with other people. And it has capabilities for staging your results from Designsafe back to Designsafe, or from your whatever storage system you're using to TACC and back. It covers a lot more than Designsafe, but is very useful for these kinds of workflows. And so TAPIS is the sort of the second pillar in this application development. And later on, we'll have a demo where Carlos will get more into pylauncher and into TAPIS and how to actually use these tools. But for now, I wanted to talk about a couple of our use cases to problems that we were able to solve by using these technologies. So the first use case was a set of storms that we got from FEMA. You know, each storm had a different track, different parameters. And what they wanted us to do was to simulate all of these storms using ADCIRC. And we actually had, initially, we were just trying to submit them one by one, kind of without developing this framework, and it was taking a long time. We ended up developing these framework using TAPIS and using pylauncher, and breaking the storms up into chunks. We found that about a batch size of 64 was optimal for each job. We could, if we wanted to, we could have submitted all 400 at once, but that would have taken a long time to wait in the queue. And using this approach, we were able to get everything done in a week as opposed to a couple of months. So that's ended up saving quite a lot of time. And the really nice thing is that after we'd done all of these ADCIRC runs, we wanted to generate visualizations for all of them. And using a couple of tweaks, we were able to leverage a lot of the same code with TAPIS and pylauncher to also generate the visualizations in parallel. And this data set has been published. It's available on Designsafe. I think if you search for Texas FEMA storms, you will find it. And here are a couple of the storms that were simulated. So for those of you who are not familiar with ADCIRC output, this is a maximum elevation plot. So it shows at each point on the grade what the maximum water elevation was during the simulation. And it's a good way to assess the sort of the worst impact of the storm. And this storm was one of the more powerful ones in the data set. As you can see, the elevation gets up to about 4 meters. That's a lot of water. But there was a whole range in intensity, in landfall location, and track. As you can see, this one's more in the middle, and this one's even less intense. And there are 450 of these that were run. We are currently working with this data set that was generated to do some reduced order modeling and machine learning, and we do have some preliminary results. Those did not make it to this presentation, and we're hoping that this data set will be very useful in the future. So the second use case for this TAPC pylauncher framework was parameter inversion. And this is the stuff that Carlos works on. So if I say anything wrong, Carlos, feel free to correct me. One aspect of the ADCIRC model we're trying to investigate is how ice affects the wind drag. And there's a lot of constitutive models for this. All of them have a certain number of parameters, and we also have some observed data. And so this is just a standard Bayesian inversion problem to try and figure out what parameters would be optimal for each of these models and be consistent with the data, and also which models best match the data. And to make the long story short, all of this requires running a lot of these forward simulations. But it turns out there's not much difference coding-wise between this problem and the famous simulations, even though it's a very different problem mathematically. The software engineering required is the same. And so we were able to reuse quite a lot of code to do this. And here are some of the results that we had. What this is showing is the observed data. This is zeta stands for water elevation. So we just we were just looking at the water elevation time series at a single output node. We generated for now, we generated just some synthetic data, just as a proof of concept. And at least for the synthetic problem where we pick true parameters, do a bunch of forward runs to try and fit some synthetic noisy data, we are able to recover these parameters. And so the next step in this research is obviously going to be to use actual data that is not synthetically generated, but is an actual observation. That is what Carlos is currently working on. But currently we're seeing some good results. And at this point, I'm going to switch off and hand things over to Carlos. We'll do a little hands-on demo to demonstrate how you use TAPC, how you use pylauncher. Here are some, and this is building off of a previous demo that was run on Designsafe. We have all of the code for the demo on GitHub at this URL. So if you have questions or you want to play around with it more after the webinar, feel free to go there and to reach out to us. And hopefully we'll be able to help you. All right, Carlos, are you ready?
Yep.
Awesome.
Let's see.
Let me stop sharing.
Yeah, if you stop sharing, I believe I can start. Okay, let's see. Okay, everyone. Just to reintroduce myself, I'm Carlos del Castillo Negrete. Thank you, Benjamin, for the great update and just summary on the research work we do. My hope here is to just kind of walk through a lot of this, how the work that Benjamin talked about is carried out through the Designsafe platform, and how just a lot of like the kind of common workflows or things that happen through a group, and hopefully through this webinar. Yeah, so the links should be, sorry, I'll answer the Q&A later, but to the person who asked, the links should be on most of the readmes and documents within the examples. But like I said, the hope of this talk is to just give people kind of like a see through how we do get things done on the platform, and hopefully get some conversation started and share some good code, and maybe get some people as well contributing in that sense. So to start off with, I'm going to just, for people who are familiar, you probably want to log into Designsafe if you haven't. I'm already logged in. And most of this stuff, if you haven't opened up a Jupyter Notebook application, then hopefully you have before through them, but you want to go to analysis and open up through Jupyter. And traditionally, when I do my analysis or interact with Designsafe, the environment I'm most comfortable with is the Jupyter Notebook. And you can access the Jupyter Notebook through two separate ways. The first of which being, I'm trying to see if I can, give me a second. Oh, here we go. The first of which being the regular, when you log in, you'll get a regular Jupyter Hub kind of like login right here. I'm personally a fan of the Jupyter Lab, the new kind of interface for it. So I'm going to continue the demo through that kind of interface. If you don't know, you can easily access it by just changing the tree URL on the top to lab. And it'll give you this nice, in my opinion, much nicer, newer interface with accessing the whole Jupyter Hub. So the basics and the goal of this kind of talk is going to be just to try to get show you guys, demonstrate kind of like the application, the pylauncher application that was kind of built and we use extensively through a lot of configurations for a lot of different types of ensemble runs. I'm going to walk you through basically the structure of the application, first of all, and hopefully through that as well, you'll understand basically how to configure a very basic run, and not just for ADCIRC specifically, but how the application can be used to configure any kind of high performance computing run in that sense. So, okay, in that sense, you want to first start off by, in your My Data terminal, you have a certain area. I've already created a webinar folder here and checked out the repository here, Tapis pylauncher. If you haven't, you would probably go to a terminal session, and you go to your, you want to check it out, right? And this is where you do the git clone command. You clone the repository that you'd want to, the repository, which is linked from over there from the example, but it's over here. The README for the repository will also give you the examples of how to clone it over here. The README as well gives a kind of breakdown of what we're kind of going to do right now, but what you can walk through as well on your own to kind of get an example. There is a setup notebook, which gives you more an idea of how to set things up. And it's particularly, you should be able to get stuff if you have a similar environment as what the Designsafe Jupyter Hub notebook default environment is like. You could set up in your own Jupyter environment, but the setup notebook is in itself written with the understanding that you're going to be in the Designsafe's default Jupyter environment in that sense. So if you run into other issues, feel free to ping me if you're setting up somewhere else, and I can try to help you. But in theory, you should be able to run other Jupyter notebooks in that sense. Then I'm going to walk through the examples between these three simple examples. One that just uses a static configuration for the HPC jobs you want to launch with pylauncher. The second one's going to be more complicated example, which is going to display the feature which we call like a generator to dynamically produce what HPC jobs you want to run. And then given time, I'll maybe talk and show some configurations for some more advanced applications like the ones we use to run the ADCIRC ensembles, and more about the application development guide. So with that, I'll just jump into the first notebook. which is regarding the, let's see, where was I? Webinar, Tavis pylauncher. So the setup notebook is going to give you an idea of how to basically go from just checking out the notebook within your environment and running it. Now, note that unlike most, there's several types of kernels you can run with your Jupyter notebooks. This is running through a bash kernel. So it's actually just a bunch of bash prompts going through here. And this is more, the purpose of this is more to show kind of like a more documented walkthrough of how the code is executed, or how you would use this what's it called, this workflow within a bash prompt or within a script to automate this kind of stuff. There's also Python. Obviously, the note, you can run a Python notebook as well, which I do quite frequently for post-processing, etc. But I like interacting with TAPIS, particularly most of the CLI. I find it to be the most intuitive with the best error messages, etc. So that's why, to demonstrate how to manipulate TAPIS in this application, I'm going to be running the bash Jupyter notebook, because the CLI itself will be running through the TAPIS CLI. Here's, like I said, where it's the person asked a question about the links. There's going to be a lot more links in these notebooks where I talk about the official documentations, etc. The YouTube video here of the previous webinar that has been given through Designsafe, I think about a year ago, is an excellent watch. If anybody here is very interested in what I've talked about, but it's kind of rough on the edges or wants to understand it better, absolutely watch this video, because it's going to give you the background and the whole understanding of what is happening under the hood. I'm mainly just kind of presenting kind of the how-to and just a demonstration how to use some of this stuff. But if you really want to understand and use this better and use it well, you really should be watching this video to start off with, and then read some of these documentations to understand what's going on under the hood, because the TAPIS API itself can be tricky to use, but it's very powerful. So with that being said, talking a little bit about the installation processes, basically your basic Jupyter Hub notebook has some kind of Conda installation in it. It should. If not, I think you can install it yourself, but I'm pretty sure you should have a default one. You want to create most likely a new environment with the necessary dependencies to run this kind of stuff. And I've actually included a YAML file with the necessary dependencies to run at least the demos included. It's included in the root directory of the repository. So you can create this here. It'll create the environment named demo. If you want to change the environment name, you can always go into the YAML file and change it to over here in demo. So once you have that running, once you have that demo, the environment installed, and you want to probably, so another clarifying point that I probably should clarify with the difference between running these examples through the bash Jupyter notebook and some of the things I have in here. Some of these things are much better to run within their own terminal. So within Jupyter itself, you can obviously run in your Jupyter notebook itself, but I also like running things that are more savvy to terminal within a terminal session, which you open over here, at least in the Jupyter Hub, to file new terminal, or you can open a new launcher instance, and this will give you a other option for terminal. But this terminal instance in itself is where I like to do a lot of my main stuff. So this is where I would recommend you to do the Conda installation stuff. And in these notebooks where I think that you should be doing this in the terminal session, I noted over here, as opposed to just, quick commands and stuff you can run through the Jupyter notebook. So once you activate the environment within the notebook, you should be able to see that the TAPIS environment, when you do which TAPIS, the TAPIS command you're accessing is in the appropriate directory. So this should make sure with this environment, you should have at least the TAPIS CLI that you want to interact with, at least the one I'll be presenting here. And like I said, if you look at the documentation, there's other methods of handling or accessing the APIs. I'm really covering the CLI more than anything in terms, because that's what I use the most. After downloading the Python environment, etc., so you have the TAPIS CLI, you can go into initializing the actual client. What's it called? There's a lot of endpoints to access through the TAPS CLI, but the main one we want to access obviously is the Designsafe one. If you have an actual TACC account, etc., you can also probably access some of these. But if you just access the Designsafe one, you're going to get a bunch of prompts, etc., that you're going to go through. Just answer them. You can not do what's it called, any of the GitHub stuff, etc. And all this is documented very well on the TACC stuff. So don't like, this is just very brief summary. Go here if you have any really questions, because this is much barely summarized. Anyways, now for the actual application that we're going to be looking at here and the ones that I've built and the one that's in this repo, there is the slight hiccup for actually using this application and distributing it that is kind of laid out here, that it will follow up. So if people are really interested in running this application, etc., there's at least 3 options here that can be proceeded. At least the application itself, since it's a privately developed application by me, it's a custom application, I have to share it explicitly with users in Designsafe for other people to have access to it. This is not public to published. So if other people wanted access to it, like my colleague over here, I can do a TAPS apps PEMS list command and get the list of people I've shared it with. And there's obviously Benjamin, who I share the application with, to use. But so if other people want access to use what's shown here, etc., but don't have access to deploy applications themselves, I can share the given distribution application I have going right now. Alternatively, if you already have permissions to develop applications yourself, to publish to deploy applications, which you probably have to open through Designsafe ticket, then you can check out the stuff in this repository, and there's a separate notebook on application deployment and development that will give you some tips in terms of how to actually change the code in the pylauncher application, deploy it, etc. But the application itself is fixed if you're just going to get it shared, and it'll only be the updates that I send to it. So like I said, there's a variety of options. You can contact me looking at this stuff if you want me to share the application straight with you, or you can be in terms of getting better access. That being said, I'm going to proceed with giving the outlines of the notebooks. If you want to run these things, get in contact with me. Okay, so giving up the setup now, I'm not going to talk once again much about like actually giving a tutorial on TAPS, etc., on the CLI. There's better resources about that, and that's not the purpose of this talk. But given the main, we're going to be mainly using the TAPS app endpoint for the CLI and the TAPS job endpoint for the CLI. Let's now discuss the application itself, the pylauncher application, and discuss it via a simple example now that we have everything set up in that sense. So for the simplest of example, understand the pylauncher application, as Benjamin talked about, pylauncher is a parametric job launcher. So at the core, it needs a set of HPC jobs that you want to run. So if we go to the simple example, job config, we have 3 main files here, if you guys can see: jobs list.csv, main.csh, and simple adjacent. So, and really it's just 2 files. So the job list.csv actually just gives us the, I don't like that. Jobs list.csv gives us the main input of what pylauncher wants in terms of the module you load from TACC. It just wants a list of inputs that tell it what to run, and you can run some kind of pre-processing here. You can run, and then the main portion of the run is what's actually run with the number of cores you specify here, and there's a post-processing run. There's more, I have the link to pylauncher itself within there, but there's more documentation within pylauncher in terms of how to configure it and run it. This TAPS application just wraps around and calls pylauncher for it to actually do the parametric job launching. So it's actually expecting something like this. So at its simple configuration level, for you to run a job that, you want to run a bunch of different kind of, shell scripts that execute something on your HPC system, then you're just giving it a list of commands in that sense. So from this simple jobless.csv, you have as well the main script that you want to run. Now, here I wrote some kind of shell script to demonstrate, some dummy process that does something, and to demonstrate here that this is going to be called by however many processes you specify here, which is 2. I put a little, you can echo things with the MPI, etc. But this is exactly what would be executed in parallel by whatever you want to do. Here's what, instead of calling main.sh in our applications, we're calling ADCIRC. Or if you're developing in other applications in Designsafe and other executables, you can put other different stuff here. Now, this at its core is really all that it needs. In reality, if we're executing some other executable that we had access to or someone else, we wouldn't need this. We would just need the list of jobs to submit to it. And then we have the input configuration for it that has specifications about the name of the application, the node count, and etc. For the actual job that we're submitting. Now, this in itself is a very simple configuration for the pylauncher application. Now, given that we've talked about how we configure it, let's look a little more into the hood about how the pylauncher application is called and wrapped by the main application. So the main application code is actually included here within the directory on top of the job configurations, the one that's actually deployed if I share with you. And with that reason, if you have your own updates, you can edit it and then deploy your own version of the app. But the main aspects of the pylauncher application are, the pylauncher code itself, and then you have the main run script, which all the main run script does essentially is that it does any kind of setup and cleanup that the main job specifies before and after running pylauncher, and then it calls pylauncher. It calls a generator script every iteration, expecting some kind of output file, which in the case, and it just looks for input files. Every single input file that it gets for pylauncher, it executes it, and then it reruns, and then it runs it again. So all it's doing is call its pylauncher with the input. So we have these ideas for running once we run every single iteration and we have no more input files to run, which in the static case, it'll be after the first iteration, we've successfully configured our ADCIRC run. So looking at the simple example in that sense of the TAPS pylauncher application, we configure it given just these 2 input files, the main, what's it called? Simple, the main executable and the jobs list. Within the code itself, it's much easier to specify. I'm going to discuss one more aspect of submitting these TAPS jobs. You can notice here within the configurations that some of these aspects of these things are templated. This is for easier deployment of the jobs in itself, that you have like a main initialization, a project initialization top level configuration, which allows for much easier templating of jobs so that you can just switch between what you're doing by just specifying what job configurations you want to run. So within here, I'm just going to specify the job configurations I want to run. So I want to run the simple test first, and I want to put the applications here. So I'm not going to run as of now because all the outputs here as of now. But if you the notebook can be looked at from here, and we can get an idea of what we were looking at before. So the notebook continues by saying, okay, here's the actual contents of the directory, which has a list we talked about before, the jobs list, CSV, the job configuration file, and the actual thing we're executing. Whenever we look at the CSV file itself, we see the exact same 2 jobs we want to run, each of them with 2 processes, each of them output to 2 separate log files, and just run as the simplest executable. here's how we actually configure the job run. Since we're configuring a more complicated job where we're actually packaging a bunch of configurations, I configure the application so it takes the applications already compressed. I found that easier and faster for tappers to take in the jobs. So here I've included just simple, commands, just zip a directory and submit it through Tappist using the Tappist job submit command, passing it the JSON file for this configuration that we reviewed over here, and the initialization directory. This actually submits the job through Designsafe platform into the HPC queue that Designsafe has allocated for itself. And we can go from there looking at the job ID itself and start monitoring the job with the Tappist job show and passing it the adequate job ID. Given the here, I'm just pulling the latest job and looking at it. So the job itself will execute. And when it does, like we said before, it's going to call pylauncher once, and it's going to give it the list of the two directories, and it's going to output here. Let's run this. Let's see what we got. Hopefully this works. Let's see if for once things work in the demo. And let's see, so, okay, so while some of this stuff is running, I can look at some of the question here for someone with zero experience in coding. Yeah, good question. So in that sense, if you're looking to run ADCIRC from a minimal coding experience and you want to actually get running examples of ADCIRC, your best bet there is to look at the main ADCIRC examples that were provided in the PowerPoint, and we'll provide links. I'll answer them here as well. I'm not sure if the PowerPoint will be available, but there's 2 links there to ADCIRC, and those will provide you links to actual documentation on ADCIRC itself, which can be complicated. But there are some simple example files there that are available that you can probably load in yourself, and using those simple example files. I would recommend you using the front end, the workspace here portal to use the ADCIRC tool from here to just give it the static set of input files. Let's see, simulation here. Use the ADCIRC one over here and configure it. Not really the target of the webinar right now, but just to answer the question for all the people out there who are like, oh, this is a little over top, I just want to understand how to run ADCIRC. This is what you want to start off with. You want to start off with looking at ADCIRC user guide and getting started with some of these, getting some test input files from that from these user guides that are linked, and those will help you get running with some of these. For the instance of us running more, what you're looking at here and what we're presenting here is definitely a much more advanced method of running large batches of maybe customized versions for these ADCIRC jobs. So yeah, so let's see, we get this to run. Let's see if it's showing here. Let's see if it hopefully ran through. Let's see. Oh, I wasn't able to find the input file. Where did I change it to? Downloads, inputs. Oh, I know what's happening here. Okay. Yeah, so any file's not right. Let's do. Sorry, buddy, bear with me shortly. And that should be better. Yeah, so the input directory will tell it where, and this is that shit's input. It's in, I guess, I did not commit the new version of this file. Okay. That should hopefully work. So I can resubmit now by just running this. I mean, this will give a little look of what the exact development process of this works as well. Like, oftentimes I'll make a mistake on how I configured a particular job, and after submitting it and looking at the report from Typist Jobs Show, I get the last status message. Right, I look at this is my main thing I look at, which tells me obviously it can be a convoluted message sometimes, but if you look at towards the end, I tend to start from to look at what's the first thing, and it says very clearly that a remote path wasn't found, which makes me think that the input wasn't found itself. And I went and reconfigured it through the initialization file, and in fact pointed it to the right one because it should be in this directory: notebooks, pylauncher, notebooks, data, inputs. Yeah, there it is. Okay, so now let's see if this actually configured and ran. No, that's the wrong one. Here it is. And if not, we'll continue with this. I'll use this captured output from the past runs to continue on and give at least 2 minutes. 10 minutes for questions. No, still not finding it. Anyways, so given that I could have configured the input file correctly. Oh, it's because I'm getting stubborn here. Gotta be stubborn to be a good coder. Hopefully the examples I try to make, in the interest of time for the webinar, because I know no one wants to be. We have about 10 minutes left. I want to give people a chance if anybody has questions. And if people have questions, you can ask in the Q&A. If not, I'll keep going in that sense. But these jobs can be, in general, commenting about working with the Typist system to configure these jobs, etc. I will say that it can be challenging to develop application or like test applications that are running on the remote system, especially through such a cycle of testing and going through the API to actually run your code. But I will say that in that sense, my advice is always to start small with things and then build gradually and use. Oh, there you go. You see, finally now I'm not getting an error message from the input. And I'm getting it's transitioned from queue to running, and it's in monitoring. So it's actually gotten the running state. So that's cool. Finally, I can look at this, and I can actually use the jobs outputs list now to see what's in my job directory as it runs. And I have actually the job as well configured to archive after it's done. We can see that, as we saw before, each process created its log file, run 1.log, run 2.log, and each process can create its output file, output 1, output 2. Now you see this is obviously very roughly configured. If you had hundreds of ADCIRC runs, dumping output files to the same directory, et cetera, get really messy, et cetera. So really, you have to configure these parametric jobs for larger jobs a little better to run something more useful, and then download. I'm not going to download things individually. Probably want to accumulate data, et cetera. That's why this simple example is just here to demonstrate how to run it at its basic. But basically, most instances that we run do a little more elaborate pre-processing, post-processing, and then set up and clean up processes, along with maybe dynamically generating jobs based off of inputs. For that, we a little bit of discussion and look into that. There's the next example included here, which is the generator example. And this is really when you get into the powerful nature of the configuration of this application. So you can use it for all sorts of complicated HPC workflows. This going in, looking at just the difference in terms of its structure, as opposed to the job configurations for using a generator as opposed to just a simple one. Remember, simple is just the CSV file of the inputs and whatever you're executing. The more complicated generator has whatever we're executing, the main.sh, but you'll notice it has a bunch of other files. It has a setup file, it has a cleanup file, it has a pre-process, a post-process, the same main execution file and a generator. So what's going to happen with this one, if we look at the generator and people are familiar with the generator shell script is just going to call the Python. And that's just because I like running things in Python for more complicated things. And I think it's clearer. And what you'll see here is the generator script for Python just calls a generator function. And all it does is it outputs a similar configuration as we saw with the main configuration, except it's in a JSON or a dictionary that outputs a JSON that has the cores per job, the main command to run, the pre-process command to run, and the post-process command to run, which now the pre-process command to run is not just some echo whatever demo thing. It's actually a shell script over here that we have, as well as a post-process. The generator, so the generator shell scripts call every single iteration. The main execution loop runs this on a loop and calls this generator function every single iteration. Now, for the purpose of this demonstration, I have a simple check here that says if the iteration of this being executed is the first time, just only iterate it once. So that prevents us from doing this. But you can think of, for our ADCIRC runs examples, we have this running as long as we have jobs left to run or jobs haven't errored. You can put in a check-in loop every iteration to see if any jobs have left to run, or like you said, fix inputs that I've run or try to rerun jobs that errored out. This is where the generator logic in the application gives the user, or how we configure this application, a lot of flexibility. So whatever needs to happen here as well with the input files that need to be configured to run can happen here and be programmed. So this is a very simple example of the generator's function that can be written, but with this application, you can run any kind of generator function, test it within your own environment to see what kind of input files it generates or what kind of configuration for pylauncher generates, and from there use that to configure a parametric job for ensembles. To go over a little in the ADCIRC sense, we use this function to go in and out and configure the different parametric jobs, the different storms we're simulating, etc. We use the pre and post processing scripts to set up the runs and then compile the ADCIRC data runs for each particular runs. And we use ADCIRC itself to make the runs. So to wrap up a little bit, feel free to check out the repo if what you're interested in here was over your head, but you want to understand it more. And this looks like stuff that could be useful to you in the Designsafe platform. I emphasize in the setup and in the initial ones, there's a bunch of really useful links. I'll try to include them and incorporate them in the root level of the GitHub notebook as well. Look into them and hopefully this may have been useful to somebody. With that being said, I guess I'll open up to any more questions or let other people. I don't know, Scott, how I'm doing on time or.
Yeah, you're doing great. Thanks a lot, Carlos and Benjamin, for a great webinar, and to Clint for kicking us off. I do have a couple questions. I guess first, I have to say I'm impressed with your debugging ability when you've got all these people watching. It's much harder to debug when you've got 65 people watching you, right, sharing your screen. I had a couple of questions. One, you mentioned that you shared an app with Benjamin using the command line interface. Mm-hmm. And it wasn't clear to me whether that was the pylauncher app itself or just a particular configuration using pylauncher that you were sharing.
So that's the pylauncher app itself. So it's a good question because there's a lot of configuration going on here, and the pylauncher app itself is just the simple wrapper script around the pylauncher module that is packaged into the TACC application to be executed. So that application itself is deployed within the TACC system as a registered application, but it's not a public application. So only I can see it to that sense, or the people I've shared it with. If I wanted to publish that, I think someone with adequate permissions has to publish that as well. And here's where Charlie can probably clarify better in that sense as well for me. But that's my understanding. So I've shared with him the Python application itself, and then given with that, he can write his own job configs for the pylauncher application and execute it there.
Okay, so if somebody wants to use it, they need to reach out to you for you to share
Yes.
it with them.
At the
Okay.
moment, they need to reach out to me. I guess if there's enough demand and people want, et cetera, there could be looking in terms of it being published as a public application. It probably wouldn't be one on the front end, but one that via the API access. But yeah, for now, if people want to, they can shoot me. I've included my info here as well on the GitHub link, et cetera. And I can give me your username and I can just share the application with you. And I'm more than happy to help you out.
Okay, and then my second question, does your example problem actually run ADCIRC, maybe like just some really light simulation, or does it just generate some shell commands that get printed out to the screen?
So for the purposes of webinar on this demo, they just run demo shell commands, etc. I have the configurations for the ADCIRC runs, and the main reason for them not being included in the webinar, the demo just as of yet, is because I don't have them pointing to that adequate ADCIRC versions from Designsafe in that sense.
Okay.
So a lot of the stuff we do with the, for example, primarily what I do with the parameter inversion and stuff, we'll play around with ADCIRC versions, implement some new parameterizations, etc., and point a lot of these things to custom ADCIRC executables, etc. So configuring that is what is kind of preventing that in terms of the ADCIRC workflow. But yeah, in theory, you could write instead of what I wrote as main.sh, you could write there the path to the ADCIRC executable for Designsafe, which your instance should have access to, and that should run that Designsafe executable. More than anything is that command that you run at the beginning has to have some executable that your job instance has access to. So yeah, that's the most important part in that sense. So I don't have an example with it here, but I will look to include one shortly, especially if people are interested in that sense, because it is just a matter of changing that main.sh command.
Okay, great. And we did receive some questions in the Q&A, but I think those have all been answered by Clint. I don't know if everybody can see those answers. I know that I can as a panelist, but if you're unable to see the Q&A, there were questions about SMS that Clint answered. You don't need to use SMS to do the work that they're discussing today. There were some links to a GitHub site and a YouTube video, and then also there was another webinar that was done on ADCIRC back in 2019, and I posted a link to that video, which was more about just using ADCIRC instead of doing these ensembles. So if anyone has questions, feel free to reach out, and otherwise I think, Charlie, we can hand it to you.
Fantastic. Thanks so much. First off, it was really cool to see how you've integrated a lot of the TACC technologies into your workflow. And it's really cool to see, especially things like pylauncher, which this is the first time I'm seeing pylauncher as part of a Designsafe workflows. That's actually really cool. So thanks a lot, Carlos. Thanks a lot, Benjamin. And of course, Clint, on joining us today with your presentation on this. It was very useful knowledge, and I'm sure our attendees would agree. So let me go ahead and share my screen and give you some closing thoughts here. All right, so this has already come up. We'll talk about real quick. There is a training archive. So as soon as this webinar is archived and videos made and the videos curated, we will publish it to our Designsafe training archive, which is available by that URL, or you can go to Learning Center training, and then the archive is down there as well. Where we have all of our videos for actually since day one of our Designsafe training available at the archive, and of course on our YouTube channel. And finally, if you're still wanting to reserve your spot and get your data set so you can be nominated for the Designsafe Dataset Award for 2022, please get your data published by January 31st. We are still taking nominations for that. Some of the perks are you'll be featured on the Designsafe's main page and a news story done about you and your data set, as well as you'll have the option of presenting your data and your findings in a Designsafe webinar similar to this. And once again, we really appreciate your feedback. So if you have feedback for us, please click on that QR tag. Just take your phone, take a picture of it, go to the site, fill out the questionnaire, and we can bring you content that is relative to your science, and we'd appreciate that. Thank you. And once again, thank you, Clint, Benjamin, and Carlos for your presentation today. We really appreciate your time and efforts on making basically expanding the capabilities of Designsafe and showing the rest of the community how you're using it. We really appreciate that. Find us on Slack, everybody, if you have any questions or some feedback that you'd like to give us or the presenters. You can find us on the general channel on Designsafe Slack, or email training@designsafe-ci.org, or fill out a help ticket under Designsafe and help, and then fill out a ticket. Once again, we appreciate your time this afternoon. Thank you very much. Stay tuned for our news on Designsafe, and see when the next webinar is going to be. Till then, it was a pleasure having you, and we'll see you all next time. Thank you. All right, so with that, stop the recording.